All right. Hey, everybody. Welcome to the ChainLinkGod podcast, where we break down the information asymmetry on all things blockchains, oracles, and smart contracts. So, today on this episode, we're going to be discussing the modular blockchain thesis, a relatively newer approach to improving the scalability and therefore throughput of blockchain networks. We'll dive more into this episode about what exactly modular blockchain is, but in general, if you've been in this space, you probably are aware of an implementation known as rollups. These days, the most popular implementation are Ethereum layer twos, so like Arbitrum, Optimism, ZK Sync, Starkware, and so on. But what many people don't know is that Ethereum rollups are not the only implementation of a modular blockchain. There's actually many different flavors and a diverse array of different ways you can implement a modular blockchain, and you can even have a rollup execute without a settlement layer in the form of a sovereign rollup. So there's a lot of different ways to approach it. And one of the projects that is at the forefront of enabling modular blockchains and exploring this broad design space is Celestia, the first modular blockchain that's focused specifically on data availability and consensus. So who better to talk about Celestia and the modular blockchain thesis in general than the co-founder of Celestia himself, Mustafa. Welcome. How are you doing today?
I'm great. Thanks for having me on. Looking forward to it.
Absolutely. So just to kick things off, could you introduce yourself and provide just a little bit of background about who you are and how you got into crypto in general?
Sure. So, as you mentioned, I'm the co-founder of Celestia. I first got into crypto because even before I heard of Bitcoin or before Bitcoin was around, I was generally interested in peer-to-peer and decentralized systems. So, like back before the Bitcoin days, we also had a community of people that were interested in decentralized networks. There was things like there were like peer-to-peer file sharing networks like BitTorrent and eDonkey, and people were thinking about how to create decentralized network protocols. And I was kind of involved with that and was very interested in that. And um, you know, I first got into decentralization when I kind of started using like pirating torrents of like movies and things like that on the Pirate Bay. And because this website used BitTorrent, that's how I first kind of got involved into this area. And so when Bitcoin came around, I was naturally very interested in it because I was really interested in kind of decentralized networks.
Very interesting. Yeah, I think a lot of people have had their fair share in using BitTorrent, using different client softwares. It's not crypto, but it is a lot of the same thesis. I know you have you have a rich history before you got into crypto, and maybe before decentralized systems. I'm not sure, but could you provide a little bit of context about like your association with Anonymous and specifically LulzSec? Like, what's kind of your background and association there?
Sure. So when I was a teenager, I was about 15, 16, because I was kind of interested in as an extension of my interest in decentralized networks, I was interested in this something called hacktivism, which is kind of like using hacking into organizations to try to reveal information that exposes wrongdoing, for example. So when I was about 15 or 16, I kind of ended up on these chat rooms, on these online chat rooms, and I kind of found myself kind of talking to other people that were participating in kind of internet activism under the banner of Anonymous. But they weren't actually doing any hacking. They were kind of just like doing something called a denial of service attack, which isn't actually hacking into anything. It's just shutting the website down. So I kind of like took that a bit further, and I co-founded a kind of hacking group called LulzSec, based on people that I found in these chat rooms that seemed to have some hacking skill. And then we kind of like went around hacking into quite a lot of organizations, partly for the purpose of kind of to expose wrongdoing. So we hacked into organizations like Fox, Sony, the Department of Defense contractors, and so on and so forth.
Yeah, it's definitely a unique background. I think a lot of people in the crypto ecosystem don't come from that unique of a background. I think, and I'm sure the hacktivism kind of a philosophy and approach, I feel like that paints a lot of your view on crypto in general. Do you think this ties into kind of sovereignty? Why is that kind of an important attribute for chains to be able to be sovereign and hard fork in terms of governance?
Yeah, for sure. for me, I was interested in hacktivism because for me it was kind of a way to like distribute power to people in the sense that anyone, I was just a teenager with a cheap laptop, and I could hack into all of these organizations, and it was kind of like a way to transcend the bell curve of power in a way, and to it's kind of like a David versus Goliath thing, where even though certain corporations or governments might have more resources than you, you could still kind of like distribute power from them. And to me, blockchains kind of really embody the same kind of ideals in the sense that they also redistribute power to ordinary people away from centralized parties and middlemen. And the reason why I think sovereignty is so important is because, to me, the key thing that blockchains enable is the ability for large groups of people to have an agreement with each other, or to have like a social contract with each other, and to be part of the same system without having to go through a middleman, or to have to appeal to some higher authority. And that's not really possible with traditional organizations before blockchains were around. For example, if you wanted to create a company, that would be incorporated under, like, let's say, in company law or corporate law in the US, which ultimately derives its authority from Congress, which ultimately derives its authority from the Constitution, which ultimately derives its authority from what I would describe as like this shared social contract that the citizens of a country have. But blockchains are interesting because it allows people to create what I would call top-level social contracts, in the sense that you can create like a DAO or a system organization that has rules that can be enforced without needing some higher level authority or social contract to enforce those rules. And this is really important because I believe that the ability for people to kind of like organize, that people with shared goals to organize, is a fundamental human right.
It's funny that, when you say that, most people would agree with that, I think, like in principle, but then when you actually put that into practice, this is very controversial to the way the world works today. It's just it's funny how that dichotomy happens.
Yeah, for sure. But I should also preface that I mean, I don't know what you're referring to, but maybe you're referring to like people.
Well, just
people,
like the ability for people to just self-organize without, having to always go through, basically without doxing yourself, or without, going through all these traditional structures. And I get certain structures are there for certain purposes, but it's just like, basically you have no private right these days, or you have to go through some official system and all this kind of stuff.
Yeah, exactly. And that's why I think it's so important.
I kind of see it as almost like blockchains are kind of re-architecting the structure of trust from a top-down type system where you have to give permission to more of like a bottom-up. You start from a permissionless substrate and then you work upwards. And it's kind of, at least I kind of see it as it's social consensus all the way down. We'll get into modular blockchains in just a second, but do you see like layer 2 rollups on a specific blockchain as kind of violating that sovereignty, where you can't deviate, you can't hard fork, you can't actually change things unless you introduce a level of permission via like upgradability in governance? Like, does that like violate this principle with layer 2 rollups?
Yeah, but first of all, I would say that's exactly right. I see blockchains as what I would describe as grassroots technology. It allows people to kind of organize from a bottom up perspective rather than a top down perspective. But in terms of your question about the rollups, it's definitely the case that if you use a shared smart contract platform, and like, for example, you have an application on a shared smart contract, or even a rollup or a DAO on a shared smart contract platform, like Ethereum or Solana, obviously the application is sacrificing some sovereignty, because ultimately that application is using the same kind of like chain as other applications, which ultimately derives its authority from that layer one social contract, not the application social contract. So, which means that effectively the rollup or the application is not sovereign because it does not have its own social contract. Instead, it's just kind of like underneath a different social contract, which is like the Ethereum, for example, social contract. For example, like you have the Ethereum EIP process and governance process, which is kind of encapsulates every application and rollup underneath it. For example, we had like the DAO hack, for example, happened in the DAO hack was an example of that. For example, you have like it relied on Ethereum social contract to fork an application inside of Ethereum.
Yeah, in many ways, it's almost like you're outsourcing the social contract to a different layer. Effectively, I think it's a good segue to get into like rollups are one implementation of a modular blockchain, but like what exactly is a modular blockchain and how does it differ than a monolithic blockchain? I think that's kind of a good substrate to kind of break this down to the listener as like, how do modular blockchains overcome the limitations of monolithic chains?
Yeah, so first let's describe what is a monolithic chain, because monolithic chains are the standard chains that everyone is used to. And what happens in a monolithic chain, which is existing chains, like Ethereum 1 and Solana and Bitcoin, is the participants or the nodes and validators in the network, they kind of do all the functions in the network, which are specifically things. They do consensus, which is they order transactions, and they also execute and do computation to verify that those transactions are valid. But it turns out that it doesn't have to be this way, because you can actually kind of separate out those components into different layers of the stack or different chains. So for example, like let's take Bitcoin as an example, right? With Bitcoin, like if you run a Bitcoin full node or a miner, you're not only just including transactions in blocks, but you're also actually executing those transactions and doing like some computation over those transactions to actually interpret those transactions. But what we can do is we can have a system where we can have something like Bitcoin, but except that the validators are only responsible for one thing, which is just including data on the chain. And it's responsible for the applications themselves to interpret what that data means. And so what that means is that the validators are only responsible for what we call data availability and consensus, but they're not responsible for execution. Instead, the actual application itself is responsible for interpreting the data on the chain and doing execution over it. And this is basically how rollups work, right? So if you take the standard Ethereum rollup, the validators or the miners on the Ethereum chain, they're not executing the transactions inside that rollup. They don't know what people's balances are inside that rollup. All they're doing is including the block data of that rollup inside the chain. So they know what the data is, but they're not actually interpreting that data, except when there's like a fraud or validity proof. And this is a much more scalable way to build blockchains, because it's just not realistic to expect in a standard blockchain for the validators to have a shared execution environment where they have to process everyone's transactions for every single smart contract. Instead, what rollups do is they only use layer one for data, but not execution. And then each rollup chain is responsible for its own execution.
Gotcha. I think just to set some context for listeners, at least in my mind, when it comes to scalability is not just more transactions a second. It's very easy to do if you just make the blocks bigger and you make the blocks faster, and then you kind of turn into PayPal or some centralized service provider. Like scaling throughput that way is very easy, but I think the goal really for blockchains is scaling throughput while maintaining low hardware requirements so that anybody can verify the ledger. So kind of a modular approach, like you mentioned, is basically you can store data on a layer on a specific blockchain. It doesn't interpret it, it doesn't execute it, it just stores it and makes it available. And then another layer can execute it and basically leverage the other layer for storing the raw data and the raw information needed to rebuild whatever the state of that chain is. So I think the scalability gains is basically you can have execution be much, much quicker, because then it can settle on a different layer that is much more decentralized because it doesn't do as much. Is there any other fundamental advantages of modular chains beyond the scalability gains that they provide?
Yeah, so another major advantage of modular chains is that because the layer one is not responsible for execution on the rollup chains, you can now have a different execution environment on the rollup chain. And that means like developers have a lot more flexibility in how they develop the application. You know, for example, you know, a lot of Ethereum rollups right now are EVM, you know, equivalent, but there's other like rollups that, like Fuel, for example, which is not an EVM rollup, but has certain innovations compared to the EVM. For example, like you can parallelize transactions, which makes it more scalable. But there's also other benefits of being able to choose your own execution environment, which include, for example, there might be things that you want to do that are just too expensive to do in the EVM or the layer one's execution environment. And one of those use cases are, for example, like private transactions, which can involve a lot of kind of cryptography that might be computationally expensive. And so that's why, for example, like Aztec is a rollup, because it would be too expensive to do all of the cryptographic computations that Aztec needs on the layer one. And so like Aztec is a privacy preserving rollup because it's defined its own execution layer for private transactions.
Yeah, I think it's an interesting point that I think some people assume if you're like a layer two or you're a rollup of some kind, you have to be EVM, but you don't. EVM has network effects, but I think there is a lot of innovation that can happen in the VM layer, and rollups make that very easy because you can outsource the security concerns, and then you can basically innovate and iterate on top of this additional layer. You mentioned like a bunch of these different terms, you know, modularities, splitting things into different stacks. And a lot of people define this as data availability, consensus, settlement, and execution. Could you kind of define what each of these layers are and what makes them different?
Sure. So let's start with, I guess, the bottom of the stack, which is consensus. Consensus is basically just taking in kind of like bits, like messages, like arbitrary messages of data, and then agreeing on what the order of those messages are. So, you know, let's say like there's message A, B, C, D, E that came in to the network. The nodes need to agree in what order they came in. That's all consensus fundamentally is. Then above that, you have data availability. And what data availability does is it makes sure that when the nodes agree that certain messages have a certain ordering, there needs to be a guarantee that the data in those actual messages have actually been published to the network, so that people know what the actual messages are.
Can you describe why that would not, like, I think most people might not understand why was that not published to the network? Like why would it not be?
Yeah, good question. The reason why is because in pretty much like, you know, most or all blockchain networks, the thing that you're getting consensus over is not necessarily the raw data of the block, but a header of the block, what we call a block header. And that header kind of contains like what we call a Merkle root to the data. So it's like a commitment to the data. And that's necessary because otherwise it would just be too slow to arrive at consensus if you would have to redistribute the entire like block data to all the nodes, for example. Does that make sense?
Yeah, I think maybe some people might not even know like what a block header even is. if they're not super familiar with the chains, like versus the raw data versus the block header.
So it's kind of like maybe we can use an analogy. So it's kind of like you can think of like a parcel, right? When you an unopened parcel, like an unopened parcel contains the address and some information about that parcel, and it might contain some information about what's inside that parcel if it had to go through customs, but you might not necessarily know like what's inside that parcel. And so like that's kind of similar to, you can think of a block header as the information about that parcel, like the label effectively on that parcel, but the data is actually what's inside that parcel. Does that seem like a good, reasonable analogy?
Right, it's like the raw transactions to actually verify that all the puzzle pieces are there. You actually have to compute, put them all together. But in the terms of transactions and blocks, you actually have to do all the transactions to make sure that all the computation is correct. Is that right?
Exactly. But actually, to continue with the analogy, kind of the other reason why data availability is important is because as you said earlier, that scalability doesn't just mean increasing throughput; it also means increasing throughput while allowing end users to verify the chain or verify that the chain is correct. Data availability is important because there needs to be a way for like nodes or like what we call light clients, like that are running on wallets of ordinary users. There needs to be a way for those to verify that the block data has been published without actually downloading all the data in the chain, because otherwise that would be too inefficient. It would be kind of like if every single person had to open the package to inspect it, like that just wasn't scalable.
And if I could just further on that point, I think what a lot of people don't quite understand is actually the different role in block production versus consensus. Like you have miners and validators, which simply just put the transactions into blocks and propose them. And actually you have all these full nodes, which you want to extend far beyond just the miners. Basically you would hope that almost anyone could run a full node. That's like the whole purpose of trying to decentralize a blockchain, is that anyone could verify the blocks that are submitted by miners. You want to keep those requirements low. And so you want people to be able to check the blocks without having to basically compute every transaction within those blocks.
Exactly. And this is what fundamentally, this is the fundamental difference between Web 2 and Web 3, or the fundamental difference between like a centralized MySQL database and a blockchain. Like if you're trying to build a normal database on Web 2, you can already do that with like a zillion transactions per second. But like end users can't verify that the operations in that database or how the database was updated was done correctly. But what differentiates blockchains is that the fact that users can run nodes to actually have a local copy of that database to make sure that the block producers or the validators have actually produced the correct blocks and have updated the database correctly. And that's basically that's the whole point of what makes blockchains decentralized, because you don't have to trust the validators. Because if the validators cannot steal your money, unlike Web 2, for example, where the people that run the database can arbitrarily change the database.
Yeah, kind of to tie it together, I think it ties into like what is the security model of blockchains, and people kind of assume that that block producers can just do whatever they want. If you have a 51% attack, it's over, like it's game over. But in reality, if you have a strong culture of people running self-verification full nodes, then everybody can hold the block producers accountable, where block producers can't steal funds, they can't just mint crypto, and they can only engage in a very limited set of activity and keep the chain going, but they don't actually control the chain. Ideally everybody would kind of run a full node, but that requires basically executing all the transactions. And so it seems like increasingly Ethereum and a bunch of other blockchains are moving towards the goal of like centralized block production, decentralized verification. And that kind of comes into what you mentioned, Mustafa, about light clients, where you don't download any of the data, or you don't download all the data, you don't execute all the transactions, but rather you just follow the block headers, and then you get some kind of proof that the data was made available. So you see this as like, that's the fundamental security model of blockchains, and that's how we'll scale them. Everybody is going to be running light clients in their browser in a couple of years. Do you see this as being kind of the inevitable future of blockchains?
Yeah. Yeah, I think like I do see this being the future of blockchains, because I think that I think like, you know, other major projects seem to agree. Like the thing that's missing the most in Web3 right now is decentralized infrastructure. Like, for example, right now, if you run a MetaMask, you're just using Infura, and you're just trusting a centralized service to tell you what the state of the chain is. But actually, this is very specific to Ethereum. Like, for example, Bitcoin actually has pretty good light client support. Like, you can download a Bitcoin like wallet on your Android phone that connects directly to the Bitcoin network and talks to nodes there directly and verifies that certain transactions were included in the chain, and without having to like use some centralized API. And this is really important, because again, this is what differentiates Web 2 and Web 3. The idea that the database is verifiable and that validators cannot corrupt it.
Yeah, this is, if I could just further, just really quickly, I think that's what people don't get is like, if everyone can participate and run a node, the miners, if they submit invalid blocks, then they just get rejected, and basically they either lose money basically, whether they lose that in the computations they run in proof of work, or they lose their stake in proof of stake. So like, it's like fundamental to the security model. A lot of people just think that the security model is because there's just a bunch of miners checking each other, but that's actually not the case, or it shouldn't be the case, at least.
Yeah, but and the reason why this is so important, which is kind of like what I was talking about initially about sovereignty and social contracts, is that like everyone that uses Bitcoin and Ethereum kind of have this shared social contracts, and that they agree on what the rules of the chain is. Like, here's the rules, like you can't steal people's money. These are the transactions that are valid. But if people aren't running nodes to actually enforce that, then the validators could arbitrarily change the rules without end users being able to kind of do anything about it. And this might not just be like some like hack, or like this might not be just because they're trying to steal your money, but this might be because, like, for example, they're compelled to by like the government, for example. They might say, hey, you have to change the rules of the chain now to transfer these funds here, for example, or whatever way that is not aligned with the actual social contract of the Ethereum community.
Yeah, I think it's really the fundamental model of blockchains that I think people like. Ideally, we make it as easy as possible to run a full node, but the best way to go about that is basically make it as easy to run a light client as possible. I think kind of diving back into like the conversation of modular blockchains, what are the different ways that you could really architecture and create a modular chain? Like, we know about rollups, Arbitrum, Optimism, like those are very popular, but that's not the only way you can make a modular chain. Like, what's the other way we can architecture this?
Can I also, one thing? Can you explain maybe like, when people say like modular chain, like it sounds like it's like one chain, but it's actually like a bunch of chains, kind of. Like, maybe you just explain that concept real quick, because I think when people say modular chain, they think of it as like some specific chain almost.
Yeah, it's funny because we also have this kind of like debate internally that like the term modular chain doesn't really make sense. But the way that we look at it is like a modular chain. We define a modular chain as a chain that outsources at least one of the 4 components that we talked about to a different chain. So, like, for example, an Arbitrum rollup is a modular chain, but in order for it to be useful, you have to use it in conjunction with other modular chains. So you have the modular stack, and the modular stack consists of multiple modular chains that together they kind of provide a coherent unit that provides all of those 4 components that a blockchain application needs, which is data availability, consensus, settlement, and execution. Does that seem?
Yeah, no, that makes sense. Yeah, I think that's that's a really good definition.
Yeah, I think a lot of people like modularity. I know some people think like, oh, Avalanche is modular or Cosmos is modular, but that's more of like software modularity. Like you can have the Cosmos SDK execution connecting to Tendermint consensus, but do you consider that to be a modular chain, or how is that kind of different?
Yes, there's a difference between a modular blockchain and the modular like kind of like node. So like Avalanche is not a modular chain because and like subnets aren't modular chains because each subnet chain is doing all of those four components, which is data availability, consensus, settlement, and execution. It's just that they're saying like the node software is modular, like because you can change the execution environment in the software, for example. But the actual network, the actual chain is still modular because the nodes are still doing all of those four functions.
Gotcha. Yeah, it is a little bit of a a little bit of confusing term because you could be modular in different ways.
Can I ask one more thing before we jump further? So you said before that consensus was determining the sequence of transactions, but when I and it makes sense on a certain sense, but when I think about consensus, like, I think about the full nodes verifying the transactions in the block, and wouldn't they be like checking things like signatures and account balances? So like sometimes when I think of ordering, I think of more like block production, whereas but in the definitions of sequencing transactions, it seems to be similar in a way. So I don't know, it creates a little confusion for me.
Yeah, exactly. That's why we have to like to clarify what we mean when we talk about consensus. Like in the traditional like academic sense, like in terms of like consensus as Byzantine fault tolerance, like you only really need the basic property of ordering messages to achieve that, because like you can achieve that by a process of what we call atomic broadcast. Like I won't go into the weeds here, but there's like in the literature there's an idea where like consensus is fundamentally something called atomic broadcast, which is the idea that you can broadcast something and everyone received it in the same order. But obviously in a more general sense, that like in a more general sense, consensus, of course, people sometimes use consensus to mean like the whole thing of not just agreeing on the ordering of the transactions, but having consensus on what the execution rules are and so on and so forth.
So it seems like in this sense, like the consensus in terms of sequencing is like you're basically accepting the sequence is correct if all the transactions in there are valid, and that everyone agrees on the validity of that sequence that was sent.
Yeah, but the fundamental point here is that on the layer 1 level, you only need consensus on the ordering to achieve like consensus on the other things. Because if everyone agrees on what the order of the transactions are, and they agree on what the actual transaction rules are, then they can also naturally come to agreement on what the actual state of the chain is and what everyone's account balances are, because they just have to like apply the execution on all the transactions in the order that they were received. So like on the layer, so the point is that on the layer 1 level, you don't need to have you don't need to bake in execution into the consensus rules on a layer 1 level. You just need fundamentally, once you have agreement on the order, you can have agreement on everything else easily.
I think they kind of one area of the stack that I'm most fuzzy on a little bit is the settlement part of it. I guess is settlement like consensus over the validity of transaction, or how does settlement different than consensus?
So by settlement, what we mean by settlement is basically a way for different rollup chains to bridge assets to each other. And so you might, for example, have a settlement layer where different rollups like post their headers and proofs to some single settlement layer, and they can kind of transact through that settlement layer. It's kind of like how Swift the Swift banking system provides settlement, doesn't provide it, but it helps provide settlement for different banks across the world. That's also, by that, we mean settlement in a similar way, which is to help different rollups bridge assets to each other.
It's kind of like, I kind of think of it in two senses. One, it seems like potentially deposit withdrawals from a specific chain, but also like if you have sovereign chains, how do they interoperate? How do they settle like with one another across the chains? So it seems like it's kind of could be both of those.
Yeah, I guess I think sovereign chains is like a totally new concept that a lot of people don't understand. Like how does this, what is a sovereign chain? How's that different than like Arbitrum or something?
Yeah, so this kind of goes back to your earlier question, which is what can you do with a modular stack? Like how can you build on a modular stack? Like most people are familiar with like Ethereum rollups, which is like one kind of way to build on the stack. And Ethereum rollups are kind of like L2s to Ethereum in the sense like they kind of extend Ethereum, where they're kind of like baby chains to Ethereum. But there's a very kind of interesting piece of history here, which is, back in 2013, before Ethereum was around, there was this thing called Mastercoin. Like Mastercoin was kind of like a predecessor to Ethereum, where that kind of used Bitcoin as a data layer. And the idea was like Mastercoin was kind of like a kind of a, not a smart contract platform, but like a platform for different other kinds of blockchain applications. For example, like Tether is built on Mastercoin, and it basically used Bitcoin as a data layer, but not as an execution layer. And so that's kind of like fundamentally kind of like a roll up, because you're using the layer 1 for data availability, but you're using like a different layer or different chain, which is like the Mastercoin layer for execution. But Bitcoin has no idea what the Mastercoin layer is or interpret anything inside of it. It just processes the raw data. And this is how Tether actually works today. If you transact Tether USD using the Omni or Mastercoin protocol. But the interesting thing about Mastercoin is like it didn't have like an asset bridge to Bitcoin. Like you can't transfer Bitcoins to like the Mastercoin, because it wasn't a layer 2 to Bitcoin. It was just its own independent blockchain that happened to use Bitcoin for data availability and ordering. And so like Mastercoin could fork easily and without Bitcoin knowing about it. And so that's what we mean by a sovereign blockchain or a sovereign rollup. Like the idea of a sovereign blockchain is that like a layer 1 is a sovereign blockchain. Like if you deploy a Cosmos chain, it's a sovereign chain because it's its own chain and the community has its own social contract over it and can hard fork it and has its own kind of governance. A sovereign rollup is basically like that. It's basically like a layer 1 chain, but the only difference is that instead of that layer 1 chain having to have its own validator set that has consensus over chains, the blocks, it can just use a existing consensus data layer and post its block there and get ordering over those blocks, just the same way that Mastercoin did with Bitcoin.
Yeah, that's really interesting. I never thought of Mastercoin like that, but you're right. It totally is just using Bitcoin for DA and consensus. So it sounds like sovereign rollups basically just need a consensus and DA layer, and that's I guess the question that kind of first came up to me when I was looking into this is like, okay, where are the proofs verified? They're verified by the execution clients, right? But I don't know, could you kind of explain this process? Because I think a lot of people assume like if you have a zero knowledge proof or a fraud proof, it has to be verified on another blockchain, but that's not actually true in this model. So could you kind of step through how that works and how that's different?
Yeah, the short answer is that the proofs are verified directly and sent over the peer-to-peer network and verified directly by the actual nodes and users of that rollup chain. So, in Ethereum chains, the fraud proofs are like posted to an on-chain smart contract, which is basically acting like a client that follows that chain. But that's actually like not the norm for fraud proofs and validity proofs. Like, before ZK rollups, we had Mina protocol. Like a Mina protocol is basically a layer 1 chain with validity proofs, with ZK proofs. But those ZK proofs aren't posted on chain. They're distributed on the peer-to-peer network to the actual nodes of that chain. And it works exactly the same way with sovereign rollups.
So you basically have similar like full nodes, and people just check those and come to a consensus and update based on the consensus on whether that was valid or not.
Yeah, exactly. You have full nodes, and then you also have the light nodes. Because the difference between a full node and light node is that a full node manually has to actually re-execute and process every single transaction that happened. But light nodes, what they do is they don't, instead of re-executing every transaction, they just like rely on, like, for example, someone called a sequencer to tell them what the state of the chain is. And if the sequencer lies to them, you can prove it using a ZK proof or a fraud proof.
In my mind, I think kind of just like summing it up, like the reason kind of fraud proofs and validity proofs are so powerful is that it allows light clients, which only typically just trust that block producers are honest. Fraud proofs and validity proofs allow light clients to basically verify the work or catch whenever a block producer is being dishonest, which allows a lot more people to actually verify the state of a chain. And you don't have to post those proofs on any specific other settlement layer. You could just distribute those proofs directly to the light clients, so everybody can verify if block producers being honest without actually executing every single transaction and downloading all of the data itself. So I think that's kind of the intuition of why modular chains are a lot more scalable and can still maintain security on their own.
Could you explain why, for people, light clients in that model can verify it versus block versus the other model? Like, why is it easier for a light client to validate?
Yeah, so like, I mean, in general, light nodes help to scale both monolithic and modular blockchains. Like light nodes are just a general purpose scaling tool. Like they can be applied to monolithic blockchains as well, and they can be used on L1s or L2s. Like you could add fraud proofs to Bitcoin, for example, if you wanted to, and that would make Bitcoin light clients have the almost same level of security as a full node, for example. And so that would help Bitcoin scale. But obviously, light clients are a kind of a critical component in modular blockchains because of the fact that in a modular blockchain, the layer 1 does not execute the transactions. So you need a way to obviously prove that the transactions are correct. And if the layer 1 isn't executing those transactions, then you need fraud proofs or validity proofs to prove that they're correct without executing the transactions. But in terms of like, as we discussed earlier, where the actual scalability of a modular blockchain comes in is the fact that because you're separating the different components in the stack, each component, the nodes that are responsible for each component can specialize in that component. And so they can provide more of that specific component. Like, for example, if they're just focused on data availability, they can provide more of that compared to if they're focused on both data availability and execution, because then they're doing two completely different computational tasks on the same machine. But if you separate that out, you can get efficiency gains, and you can also have a more efficient fee market for each of those different resources.
Yeah, it's kind of a specialization in each component, so you can actually, you don't have to waste resources. You could basically just outsourcing, and outsourcing could be a lot more efficient way of performing tasks. So I think it's a good segue into Celestia, which is a specific modular blockchain that's focused on the consensus and data availability layers of the modular stack. Could you kind of, just describe an overview of what Celestia is and what advantages are gained for Celestia by not having any execution layer?
Sure. So Celestia is a project that I started in 2019 when it was originally called Lazy Ledger. And the basic idea is to provide like the most basic layer 1 that you can think of and just scale that really well, in the sense that we want to strip back layer one to its core components, which is consensus and data availability, and then just scale that really well, and then allow other developers to build execution environments on top of that, instead of us providing built-in execution environment.
Gotcha. So it sounds like it's been in development for a while. What has been what components have been working on building for this modular chain?
Yeah, so there's kind of like a few kind of key technologies involved in Celestia. The first of which is this technology called data availability sampling. And data availability sampling is this kind of cryptographic protocol that allows light clients or other like users in the chain to verify that the entire chain, the entire data in the entire chain was actually published without them needing to actually download all the data themselves. Instead, what they do is we use this technique called erasure coding. And what this kind of allows you to do is it makes it so that the validators, if they want to hide even a single byte in the block, even a tiny piece of the block, or a single transaction in the block, they will have to hide at least like half of the block, or in our case, 25% of the block, because thanks to this technology called erasure coding, it means that you can recover the entire block from only half of the data. It's kind of like the same technology used in CD-ROMs. Like if you scratch CD-ROMs, if you scratch a CD-ROM and some of the data is missing, your computer can still read that data because it can recover that data thanks to something called erasure coding. And thanks to that technology, light clients can get very high guarantees that the entire data is available by only requesting a few random like parts of each block. Because if like let's say like they request like 20 different pieces of a block, and if any of them are missing, then they can assume the data is not available.
So basically, it's if enough nodes sample the data, you can get a high enough quorum where basically you have a pretty high probability that all the data was made available, which then if all the data was made available, then anyone could have checked the proofs, and basically then the transactions, if all those security models hold up, which they should, then the block is valid, or the transactions.
Yeah, that's definitely a key component of it. You can kind of think about it like how BitTorrent works, if any of your listeners are familiar with BitTorrent, where like the idea is like, if you use BitTorrent, if you download a file using BitTorrent, you're connecting to lots of different peers that have lots of different pieces of that file. And so like instead of downloading it from one server, you can ask, hey, do you have this piece of the file? Like if you're downloading a movie, for example, different nodes might have different pieces or parts of that movie, and you can go to each one and say, hey, please send me that part. But BitTorrent is extremely scalable because it doesn't do execution. Like the more it can store insane amounts of data, because like you just need to add more nodes to the network to increase the number of files you can store. And we're kind of trying to bring a very similar scalability property to BitTorrent by removing the execution and just making it about data availability. And that allows you to construct a system where the more nodes you add, the more data, because the more data the nodes are sampling and downloading, the bigger the blocks you can have.
Yeah, that's kind of, I think that's like almost like the core, it's like a core innovation in Celestia, where the more nodes you add, the more scalable the chain can become, where in a traditional blockchain, Bitcoin, Ethereum, like you add more nodes, it's actually just more overhead. It doesn't make the chain any more scalable at all, because it doesn't scale in that fashion. So in Celestia, it's almost like light clients are directly securing the network. And then that allows you to basically increase the size of blocks. Is that right? How does the correlation between like more light clients and larger blocks play out? Is that like a one-to-one relationship, or how does that scale?
Yeah, it's pretty much it's almost a one-to-one relationship. It's slightly below one-to-one, but not like, because because the Merkle tree gets bigger, but it's almost one-to-one, which means that you can the more nodes you add, the higher the block size you can have without trading off the ability for end users to verify that the data was actually published.
Gotcha. And does this block size happen automatically? Is there like a governance mechanism? How does the network know how many light clients, like Sybil resistant light clients, exist in the network?
Yeah, it definitely does not happen automatically. And exactly because anyone can spin up a light node. So there's no way to kind of like automatically tell which light nodes are fake and which are real. And so in Celestia, we're planning for this to be a governance parameter. There'll be a maximum block size that you can kind of vote to increase up to on chain, and then if you want to go above that, there would have to be like an off-chain hard fork to increase it. But in general, the community, you can't do it, you can't increase it automatically. Like the community kind of needs to agree to increase it. We have to kind of like analyze the network to see, okay, we've probably got enough light nodes that aren't Sybils, based on these metrics, that we can probably comfortably increase the block size without trading off security.
Gotcha. And I imagine with your views on sovereignty, that this governance process is like rough off-chain consensus where full nodes have to upgrade their software client, and it's not on-chain governance voting with tokens. Like, is that the model you're approaching?
Well, it's kind of like both. So like there'll be like a maximum block size. It's very similar to Ethereum actually. It's kind of like there'll be a maximum block size that is hard coded in the chain, and you can vote to increase it up to that block size. But if you want to go above that, you need to hard fork. So it's very similar to like Ethereum's model, where there's a gas size limit that the miners can increase up to that block size limit or gas size limit. But if you want to go above that, you have to like hard fork or do an EIP.
I had a question, Mustafa. So the data is made available on Celestia. I just had how long is it stored? Is it stored forever? Is it pruned eventually? Like, I'm just curious how long that data is stored.
Yeah, so there is no in-protocol guarantee that the data will be stored forever, even though in practice it probably will be. And this is because there's a difference between data availability and data storage. Like they're two different concepts. Data availability does not require data to be stored forever, because the main point of data availability is to make sure that the data is available for a sufficient period of time so that the applications that need that data can download that data. But it's up to the applications to be responsible for how they want to preserve that data long term. And this is also the exact same philosophy that Ethereum is taking with dank sharding, by the way. Like in Ethereum, the nodes that will only store data for 30 days, because there's other protocols that are responsible for long-term storage. Like you have the Graph, the Pocket Network, Filecoin, and so on and so forth.
So would it be accurate to say like data availability is proving that data was available for other people to download at some specific point in time, but not a guarantee that the data will be forever available? That's more of download the data when it's available if you need it. Otherwise, there's no guarantee it'll exist afterwards.
Yeah, that's right. Although, like in practice, it's extremely likely that the data will always be available, because you only need like one node to actually be storing that data. You only need like at least one node. In practice, there'll be more, of course, but you only need like one person to store that data for it to be available. So it's like an honest minority assumption. And as long as you don't increase the block size to be something too crazy, then it's very likely that someone will store it. Just like people have stored the entire Ethereum history or the entire Bitcoin history.
Yeah, the argument I've heard is that like if you're running a rollup or a sovereign rollup on top of Celestia or some other DA layer, it's kind of the responsibility of the nodes of that rollup to have the data availability or have the data downloaded to their clients. And that way you don't have to actually download all the data that's on Celestia, but just specifically the data that's relevant to you. So it's each chain you can call user is responsible for its data storage, but it's just data availability that's outsourced to Celestia. So it's a specific important component plus the transaction ordering. When it comes to like transaction ordering on Celestia, since that's like a core component of it, is there any concerns about MEV? Is it less of a concern because you're not actually executing anything? How is like block and transaction reordering handled on Celestia?
Yeah, so Celestia is technically prone to MEV on the kind of like day one level, but ultimately it depends on how your rollup works and like who gets to say of what's included in your rollup blocks. So like for example, like if your rollup has like a set of centralized sequences, and it's not like anyone can just be a sequencer for the rollup, like Optimism or Arbitrum is today, you have centralized sequences, then it's those sequences that capture the MEV, not Celestia, because Celestia doesn't get a say in what's included in the blocks proposed by the sequences. But if you have a more of like a permissionless rollup where either anyone can be a sequencer or people can submit transactions on chain directly, like Mastercoin, then yeah, it's possible theoretically for Celestia validators themselves to capture that MEV.
Is that because they can see that data coming in first?
Well, I mean, it's just because that they can see the data coming in, and they can also choose what order to include it in the blocks.
Gotcha. Do you see any potential centralization concerns there, where the Celestia nodes that are executing the rollups themselves can see what the MEV opportunities are and kind of extract it for themselves, or is you see most rollups ordering themselves and kind of outsourcing this problem to the rollups to handle?
Yes, this is a very interesting question. Like, and Ethereum kind of like went through an existential crisis of this, right? Because what happened was, in Ethereum, block production became highly centralized because of MEV. And so like, Vitalik put out this post called Endgame, which kind of argued that the endgame for scalability and for blockchains is that you will have centralized block production, you'll have centralized block production, but you'll have decentralized block validation. And that's basically the core kind of like worst case scenario that Celestia is built for, like way before even like Vitalik or Ethereum kind of went to that approach. Because our approach is that because we are using data availability proofs, and we're specifically focused on allowing the light nodes or nodes with minimal resources to validate the chain, even if you have centralized block production, because you have decentralized block validation, the centralized validators still can't do anything too bad, like they can't steal money or change the rules of the chain and so on and so forth. But what they can do, the only thing they can do is censor transactions, in which case you would have to like revert back to social consensus and hard fork the chain.
Yeah, that's an interesting point where centralization is no longer a security concern because you have all these light clients verifying everything. Do you see, I know Ethereum is going down the route of proposer builder separation, where you have block builders creating blocks and they propose it to network validators, and then network validators propose that to the network. Is there any kind of PBS / Flashbots MEV boost type model plan for Celestia, or is that not any approach that you guys are thinking of?
Yeah, we don't have that in the protocol specifically right now. Like we just use Tendermint. So we don't do that. But I don't see any reason why it wouldn't be theoretically possible to do that off chain, even if the Celestia validators accept blocks from other people.
Gotcha. Yeah, that'll be, I think it's largely dependent if rollups handle ordering themselves or if it's goes fully permissionless. So when it comes to Celestia, we talked about how sovereign rollups can be created where you just use Celestia for consensus and data availability, and then execution is basically outsourced to this other layer. But what's the other ways that you can use Celestia beyond just sovereign rollups themselves?
Sure. So like sovereign rollups is definitely like one of the most exciting use cases of Celestia. But there's other use cases. Like there's also what we call settlement rollups, which are also a type of sovereign rollup. And a settlement rollup is like a rollup that has other rollups underneath it that use it for settlement. And the rollups underneath it aren't sovereign. So just like, like the Ethereum mainnet right now is basically a settlement layer for EVM compatible rollups. You can actually create your own settlement layer as a rollup itself and have other rollups underneath that. It's kind of like you have L3s basically. So that's one of the use cases. And then you've also got this idea of a Celestium. And a Celestium is this kind of like product that we're developing that allows rollups that use Ethereum for settlement to use Celestia for off-chain data availability. And it's because it's off-chain data availability from the view of Ethereum, it's not as secure as on-chain data availability on Ethereum, but it's a better and more secure alternative than just using a centralized data availability committee, which is what like current Validiums do, for example.
Gotcha. So it's basically a more decentralized, more secure way to be able to, for the ability for Ethereum Validiums, which is essentially ZK rollups, except they store their data off-chain to operate. Is there a way for, we know that light clients are able to directly do data availability sampling to make sure that data is available, but can the Ethereum network perform data availability sampling, or how does Celestia prove to Ethereum that data has been made available, or is this more of a off-chain condition?
So this just relies on trusting the Celestia validator set is honest. The Ethereum smart contract will just verify that the Celestia data like commitment was signed by 2/3 of the Celestia validators. And so it's not as secure as like doing data sampling, but it's more secure than using just a centralized committee, because the Celestia committee can be slashed if they misbehave, which adds cryptoeconomic security to the rollup.
Gotcha. Yeah, that makes a lot of sense. Like Ethereum can't directly sample it, but if the data isn't made available, then some light client can prove that and then slash the validator. So there's still a penalty even if it's not Ethereum doing it itself. So you mentioned the kind of the advantage of like settlement rollups is it basically serves as a layer where rollups could be deployed on that and can basically bridge and intercommunicate with each other through kind of a trust minimized connection layer effectively, which is a very interesting approach. Is how would rollups on a settlement rollup be able to communicate with sovereign rollups, since like they all share the same Celestia data availability consensus layer, but only some of them would be on this settlement rollup while others would be kind of standalone? Or are those rollups still able to communicate? Is there any kind of trust assumptions that arise there? Or how would that intercommunication work?
Yes, there's a huge design space for cross-chain communication between sovereign rollups and sovereign blockchains in general. And I kind of explore this in the original blog post that I wrote about sovereign rollups. But like long story short, there's many different ways of doing it. You can still do trust minimized bridging between sovereign rollups if the sovereign rollups include light clients that verify validity proofs or fraud proofs of other sovereign rollups. But the key kind of point that's required for the sovereignty is that there kind of like needs to be a way for that sovereign rollup to hard fork or upgrade itself using a fork, like without, I guess, like requiring a specific bridge to agree to that. So it's kind of like, how like there's a bridge between Ethereum and Solana, but like Solana does not need permission from Ethereum to hard fork.
I see. Okay, so the bridges is basically one rollup implementing a light client of another rollup, and you don't need permission to do that, but it really is dependent if you want to operate that light client effectively. It's an interesting approach, and I think one other kind of question I had when I was kind of diving into Celestia and reading about it was more about like the economic side. What do the economics of the Celestia network look like? Is the goal to have a fee market like Ethereum is kind of created, which is, Ethereum's expensive, but also has a healthy fee market to help support the economic sustainability of the network? What is like that structure look like for Celestia? Is the goal to become sustainable off of transaction fees and reduce block rewards over time, or what's the model here?
Yeah, so there will be a fee market and the transaction fees will be based on how much data you want to post on chain, which is like very similar to Bitcoin transaction fee model, which is based on bytes. And this is very good because like unlike the Ethereum gas model, which kind of like conflates lots of different computational resources like data, like storage and computation. So you have the same gas token for all of these different resources. So you often have to do EIPs to kind of like adjust the pricing to make it make sense. In Celestia, the gas is only paying for one resource, which is like the data, and so that allows you to have efficient fee markets. In terms of like long-term like economic sustainability, I kind of share the opinion that it's not really safe to assume that you will have like long-term transaction fees to secure the network and to like give stakers their rewards. So I think our model would be that we will have like there will be like a perpetual new money issuance of a certain percent each year, but then we want to implement fee burning at some point, so that if there's sufficient transactions and there's sufficient fees, that can cancel out the new money being issued and potentially make it deflationary, just like Ethereum is doing right now.
Gotcha. Yeah, it's a very similar model to Ethereum. Naturally, Celestia is more kind of focused specifically on one layer of the stack, but kind of using block rewards to support the network and then burning the excess transaction fees. I think that's it's a model I feel like more blockchains are going to start to gravitate towards, but we'll see on that. Kind of going back to just Ethereum here. Well, what are your general thoughts on Ethereum's approach to data availability, data sharding, what they're calling dank sharding / proto dank sharding? Ethereum's data sharding has gone through many revisions, but like, what's your take on that? Is that going to be able to scale the Ethereum ecosystem, or are they going to need even more data availability to scale their ecosystem?
Yeah, I mean, I think it's like props to Ethereum for kind of like trying to be at the forefront of, or are being at the forefront to many extents of like data availability scaling. They're definitely like leading a lot of the areas of research on this. But in terms like if I remember correctly, dank sharding, the end goal there, like if the whole dank sharding roadmap is implemented, you get 16 megabyte blocks, which I think probably it's hard to say, it's hard to predict whether that's enough or not. It might be, but it's hard to kind of predict. But in terms of how dank sharding compares to Celestia data availability scheme, so the main difference is that dank sharding uses this commitment scheme called KZG commitments to commit to the data, whereas we just use like the standard Merkle trees. There's actually there's several other more important differences. The most important one is that because Ethereum has an enshrined execution layer, that means that you can't just but there will be overhead to just using Ethereum as just a pure data layer as a sovereign rollup, because of the fact that Ethereum has an enshrined execution and smart contract layer. The nodes of that sovereign rollup will also have to take an interest in the validity of that smart contract layer, even if they don't use it, which adds overhead. And it also doesn't really make Ethereum a credibly neutral like data layer for like sovereign rollups, because of the fact that there is an enshrined smart contract layer. The other thing is that there's some differences in the transaction models of proto dank sharding and Celestia. In proto dank sharding, you can only buy I have to check this, but you can only buy like a large amount of data at a time. I quickly look at the EIP again, but it's like, I think it was like like 100 kilobytes of data at a time. So there's like 8 to 16 data slots. So it's like per block, there's only 8 to 16 like parties can buy data on that block. Whereas in Celestia, you will be able to buy like a kilobyte or less of data at a time. Instead of like you don't have to buy a huge amount of data at a time in a block. You can buy a small amount of data at a time, and that kind of makes it more appropriate for sovereign rollups or rollups that want to post data to Celestia directly in case they want to inherit the kind of censorship resistance of Celestia.
And also Celestia too, if correct me if I'm wrong, but it can support basically any, well, maybe not right away, but it's designed to support lots of different chains, not just Ethereum chains.
Yeah, for sure. Like because there is no execution layer on Celestia, and there is no settlement layer, there's no specific like requirement on what execution environment your rollup has to be compatible with. Like on Ethereum rollups, all rollups have to be EVM compatible. But there's like you can also have like WASM rollups. I believe there's like a team of people actually building rollups for Cardano, funnily enough, that's kind of like settled to a WASM based execution environment. And that's actually very interesting in the Cosmos ecosystem because there's COSM WASM in the Cosmos ecosystem, and people are building COSM WASM based chains in the Cosmos ecosystem. And those could be very interesting settlement layers for rollups.
Do you see there being a large diversity of different VMs for rollups and sovereign rollups, or do you think the EVM network effects are too strong, or do you think there's going to be lots and lots of different VMs and there's going to be a large amount of diversity? Which way do you think the ecosystem's likely to converge to?
Yeah, I definitely don't think the EVM network effects are too strong, and that's very easily proven by like Solana and Starkware. Like people, like there's a lot Solana, like there's a huge number of Solana developers, if I remember correctly, like almost as many or maybe more than Ethereum, like of last year. And so obviously it's clear that there's appetite, like people, like developers are willing to learn new technologies. And Starkware also proved that. Like they've got hundreds of Stark developers building like ZK Starks applications.
Yeah, that's interesting. It remains to be seen, but that's kind of what I like about rollups and sovereign rollups is because you're outsourcing all the security concerns. You don't need to launch a whole new blockchain to experiment with a whole new VM. You can just outsource it, and because the security is outsourced, developers are more willing to build on it because they care about security, and users are more willing to use it because there's developers building on that chain. So I'm very interested to see what language it's gonna, if Solidity ends up becoming like JavaScript, where it's not great, but it has a lot of tooling and a lot of adoption around it. So it'll be interesting to see how that evolves. Kind of on the note, do you see a future where existing monolithic chains convert into becoming like the execution layer within a modular stack? Like, do you see chains ditching their consensus and data availability layer? Like, is that a realistic possibility, or what's your thinking there?
Yeah, I mean, I think some like application specific chains might do that. DYDX, for example, has had 4 different versions on 4 different stacks. V3 was on Starkware, V4 was a Cosmos chain. So I definitely see like application specific chains deploying to different or using different technologies across different versions. Like even Tether does that. Like Tether is deployed on Ethereum, Bitcoin, and other chains. So I definitely think it's possible for application specific chains. However, I don't see like L1s doing that. Like I don't see Solana. I think it's very unlikely for Solana layer 1 to be a rollup. But what is more likely is that someone will take the Solana execution environment, sea level, and stick it into a rollup on Celestia. And then you can use Solana contracts on a rollup.
Yeah, I think I'm mostly aligned around there. I think it doesn't really make sense for a lot of L1s to kind of give up their prime real estate, the core value proposition. But application specific chains, they don't want to pay as much. So I think that my last question for you is, do you see any future for monolithic chains? Like, is there any value proposition for monolithic chains that modular chains just can't realistically provide, or is just the natural conclusion of blockchains is modularity?
I mean, I wouldn't say there is no future. I definitely think that the future is definitely overwhelmingly modular. But I'm not going to say like there is no use cases for monolithic chains. I think like ultimately everything is a trade-off, and I'm sure there might be reasons for someone to want to not to use a shared consensus layer, but might want to have its own consensus layer. And that's especially true is like if they're trying to develop like a novel like Sybil resistance algorithm, like proof of something, like proof of space, proof of whatever.
Yeah, that makes sense. It's the future is really unknowable. How I mean, it's only been 14 years since like Bitcoin, and even that's it's a short time for an industry as a whole. So I think this episode was very interesting in my mind. I learned a lot about modular chains and kind of you're thinking about how the ecosystem is going to evolve. CO, do you have any last thoughts or last questions for Mustafa here?
No, not in particular. It just got me thinking about, I think one of the current debates that's kind of starting, going on lately is it going to be this kind of like layer, like is Ethereum and their layered approach, modular approach going to win, or is it going to be all these different app chains? And, I think a lot of people are kind of thinking about these two theses now and what's going to win out. So it just spurred more thinking in that particular direction.
Yeah, I mean, it's hard to say, but my thesis is that like if we make deploying your own rollup chain as easy as deploying a smart contract, I don't really see a reason why people just wouldn't just deploy their own rollup chain, because that gives them more control and they don't have to share execution with someone else. Like for the same reason, like if you launch a website today, you would launch it on a virtual machine. You wouldn't like it would have its own server. You're not going to your website is not going to share the same server as someone else.
I guess my one, I tend to, I didn't used to agree with that. I guess my one question is about kind of composability, and if that is severely affected by that, or if that's just something that's just going to keep getting better and better over time.
It definitely does have a composability trade-off. Like obviously, if things are spread across different chains, that makes composability trickier to some extent or more complicated. But the thing is, we have to get there anyway. Like we have to do that anyway, because it's pretty clear that you just can't have it. You're just not going to scale if every single smart contract uses the same execution layer. It's like Ethereum is already splitting up its execution into different rollup chains, and those rollup chains are not do not. You have to use the bridges if you want to compose assets from one chain to another. Like we're already heading to that world because we don't have a choice, and so we just have to focus now on having really good bridging protocols. And thankfully now there's quite a lot of like teams building all sorts of different bridging protocols.
Yeah, I think I'm kind of aligned there. Like in order to scale the ecosystem, you have to go horizontally, you have to go quote unquote multi-chain, but how you go multi-chain is kind of a broader question of app specific monolithic chains versus roll-up sovereign chains versus roll-up on top of a settlement layer, or even a mixture of all of them, then how bridging is handled and the different proofs used. Like there's a lot of variables that can go into each one of them. So I'm excited to see what the future evolves into.
Can I ask one more question actually? Just because, I think Mustafa he's been in the space for quite a long time. We've been talking a lot about the infrastructure layer, like a bunch on this, and it's very interesting. And I feel like that's where a lot of people like discussing. But I feel like, one of the biggest problems is just applications, like useful applications that that people want to use. We have some, but they're very niche to this small crypto community, and if we're just only building infrastructure, so my question for you is, do you think the applications are not there yet because the infrastructure is not there, or just because we haven't figured out quite how to use this technology yet? The business models I think are quite tough. Like, I'm just curious what your thoughts are there.
Yeah, I definitely agree that I don't think the applications are there yet. Like, sure, like DeFi and NFTs are cool, But ultimately, what we've ended up in so far is like all we have is like this kind of like self-referential token casino where people like do all sorts of like weird things with tokens, but those tokens ultimately don't really have any specific, value except for trading them. And I think, that's where we are today. But I think to like really enable a broader use case of applications, then we need to, I think sovereign rollups will help with that, because a lot of these applications are limited by scalability or are limited by the fact that you have to develop your own like execution environment. If you look at Ethereum white paper, there were all kinds of like weird applications proposed, like decentralized Dropbox, for example, or like privacy preserving transactions. But a lot of those applications are like limited by the fact that either it's hard to do on a shared execution environment because certain instructions are expensive in the EVM, or there isn't enough resources. The gas fees are too expensive because the resources aren't priced correctly. So like my hope is definitely like by allowing developers to have the freedom to deploy their own chains with their own execution environments, that could like open a lot of new applications that haven't been trivial before.
It does seem like the path forward, at least in my mind, is like a lot of the being able to tokenize real world assets, having the regulation to be able to support that environment, and then also having the scalability where like it seems like every time an application reaches product market fit, they end up having to spin out to their own monolithic chain. At least that's been the approach, just to be able to handle the usership, like Axie Infinity or now DYDX. That was kind of been the approach, but I could see a future where spinning out to your own chain means spinning out to your own rollup or spinning out to your own sovereign rollup or onto a settlement rollup. So it does seem like that is a viable path.
It does make sense too, in the fact that a lot of these really cool applications that people talked about, like a decentralized social media and all these like big social applications that blockchains in theory could have a lot of benefit for, but you could never build those probably on the existing infrastructure today, because it just not only would it be tough from a technical standpoint, but it'd just be way too expensive. So I guess maybe, I think that does make sense to a certain, I think it makes sense, yeah, that scalability is holding back a lot of the best applications. Although I think we're still learning, a lot of people are still learning like how to actually build, like what's blockchains actually useful for. I think everyone thought it was useful for everything. Now it's like figuring out what it's useful for, and also how to build business models with tokens. I think that's also a bigger challenge than a lot of people realized.
Yeah, for sure. I mean, like the general concept of a DAO itself is very useful. Like, not necessarily DeFi DAOs, but like a Sound DAO is an interesting example. Like a DAOs to get people together to either a common cause, to like have a shared treasury for a common cause. Like Assange DAO, for example, like raised $50 million for the cause of like freeing Julian Assange. In the real world, that would be very difficult to, and thousands of people participated in that. And in the real world, that probably wouldn't be practical, like to set up a kind of like a decentralized DAO that quickly with thousands of members. So a lot of these cases are definitely also just about reducing friction for people to organize.
Yeah, I see blockchains basically as a neutral settlement layer, and I think both applications and the infrastructure itself kind of need to scale together. You can't just scale one or the other, otherwise, you scale infrastructure, you just kind of have a casino. You scale applications, then you just kind of neuter its growth completely. So it's really, in my mind, it's an intertwined type problem. So I appreciate having you joining us, Mustafa. I think it was a really interesting discussions. Do you have any last thoughts or takeaways for the listeners? Anything they should look into?
Yeah, if you're interested in learning more about Celestia, you can check out celestia.org. There's we have a Learn Modular section of the website which has various articles that kind of explain the modular thesis. And yeah, thanks for having me on here.
Absolutely, and I second that. Definitely check out the Celestia blog. They have great resources, and just the mental models it puts in your head is it's very informative. So Once again, thanks for coming on and have a good one, everyone.